This video will cover the turning effect of forces, including concepts like moment, center of gravity, and stability. We will learn to use the relationship. Moment equals force times perpendicular distance from the pivot. We'll also examine the center of gravity and the principle of moments for parallel forces. The moment of a force is also known as the turning effect. It's calculated as force multiplied by the perpendicular distance from the pivot. The unit is the Newton meter, or Nm. Moments can be clockwise or anti-clockwise. Let's calculate the moment exerted by a claw hammer. Given a force of 80 newtons and a distance of 25 centimeters, we first convert the distance to meters, 0.25 meters. The moment is 80 newtons times 0.25 meters, which equals 20 newton meters, acting clockwise. Let's complete this table of force, distance, and moment calculations. You can pause the video here and try to find the missing values using the moment formula. Here are the answers to the table. In the first row, 40 newtons times 3 meters equals 120 newton meters. In the second, 1,000 newton meters divided by 200 newtons equals 5 meters. The third row shows that 200 newton meters divided by 4 meters is 50 newtons. Finally, 3,000 newtons times 0.2 meters is 600 newton meters. Here is another question. Choose the appropriate words from the selection to fill in the blanks in the sentences below about the moment of a force and turning effect. The moment of a force is another name for the, quote, turning effect of force. It's equal to the force multiplied by the perpendicular distance between the line of action of the force and the turning point. The unit is Newton meters. Moments can be clockwise or anti-clockwise. The center of gravity is the point at which the weight of a body acts. For symmetrical bodies, it lies along the axis of symmetry. It is sometimes also called the center of mass. When a body is suspended, it will come to rest with its center of gravity directly below the point of suspension. The examples illustrate the weight acting through this point in the baskets. To find the center of gravity of a card, pierce it in at least 2 places and suspend it. Using a plumb line, draw a vertical line on the card. Repeat this process for all holes. The center of gravity is where these lines cross. A body is stable as long as its center of gravity remains vertically above its base. The examples show stable, balanced, and unstable toppling scenarios based on the center of gravity's position relative to the base and pivot. What factors contribute to the stability of a modern racing car? The 2 main factors are a wide wheelbase and a low center of gravity. The principle of moment states that when an object is balanced and not turning, the total clockwise moment equals the total anti-clockwise moment. For the balanced ruler shown, W2 times D2 equals W1 times D1. Let's solve question 1. Mary, 600 newtons, balances John, 200 newtons. Mary sits 1.5 meters from the pivot. We need to find John's distance from the pivot using the principle of moments. Applying the principle of moments, Mary's weight times distance equals John's weight times distance. 600 newtons times 1.5 meters equals 200 newtons times distance. Solving the equation, John is 4.5 meters from the pivot. Question 2. Calculate the weight of the beam, W0, if it is balanced when W1 equals 6 newtons, D1 equals 12 centimeters, and D0 equals 36 centimeters. Refer to the diagram for the setup. Using the principle of moments, W1 times D1 equals W0 times D0. Substituting the values, 6 newtons times 12 centimeters equals W0 times 36 centimeters. W0 is 72 divided by 36, so the weight of the beam is 2 newtons. Complete the missing values in this table for a balanced ruler, applying the principle of moments. You can pause the video here to calculate the missing weights and distances. Here are the completed values for the table. The missing distances and weights are 10 centimeters, 6 newtons, 12 centimeters, and 8 newtons. Let's look at forces on a beam or bridge. When a 24,000 Newton lorry is at the center of the bridge, its weight is supported equally by the 2 columns, A and B. Each column bears 12,000 newtons. When the lorry is directly over column A, all of its 24,000 newtons of weight would be supported entirely by column A. When the lorry is 3/4 of the way across the bridge, column B will bear 3/4 of its weight, which is 18,000 newtons. Column A bears the remaining 1/4, which is 6,000 newtons. What are the column forces when the lorry is 1/3 of the way across the bridge? Column A bears 2/3 of the 24,000 newtons, which is 16,000 newtons. Column B bears the remaining 1/3, which is 8,000 newtons. Choose the appropriate words from the selection to fill in the gaps for this final question. You can pause the video here to complete the sentences. The turning effect of a force is also called the moment of a force. Moment is measured in Newton meters. If a body is balanced, the total clockwise moment is equal to the total anti-clockwise moment. A body will be stable if its center of gravity lies vertically above the base of the body. A tractor has a large wheelbase to reduce the possibility of it toppling.